A brief history of GIS development. The interpretation of maps has been a key skill for many centuries. For numerous and varied reasons, maps have been drawn showing the location of real-world features which are of interest and then looked at and information or spatial patterns inferred by the viewer. One of the often quoted uses of looking at a map and effectively interpreting and analysing its contents that can be deemed as the early use of GIS is regarding the cholera outbreak in London in 1854. John Snow drew a map of points showing the locations of some cholera cases and the location of water pumps. His interpretation of the visual clustering of cases around a particular water pump led him to determine that the source of the outbreak could be from this contaminated water pump. The suspect pump was shut down and the outbreak ceased. The early 1900s saw the development of the capability that allowed maps to be split into layers. For example, one for contours and one for water. Although still drawn by hand on what was essentially paper, this allowed individual layers to be drawn and updated separately. The layers were then combined and printed. At this stage it cannot be called GIS, as the maps had no added value in terms of the attachment of additional information, but the fundamental idea of different spatial or geographic layers was there. The true advent of what we now know as GIS came with the development of computers and computer mapping applications in the early 1960s. The world's first true operational GIS was developed by Dr. Roger Tomlinson and was called the Canada Geographic Information System, CGIS. It was used to store, analyse and manipulate data collected for the Canada Land Inventory, CLI, which was an effort to determine the land capability for rural Canada by mapping information about soils, agriculture, recreation, wildlife, waterfowl, forestry and land use at a scale of 1 to 50,000. A rating classification was also added to permit analysis. It provided capabilities for overlay, measurement, digitizing and supported a national coordinate system and incorporated topology and stored attribute and locational information in separate files. All these factors are the basis of what we are now used to as the core of modern GI systems. Hence, Roger Tomlinson is affectionately referred to as the father of GIS. There followed a number of key developments in technology, particularly at Harvard, and the foundation of many of today's leading commercial vendors of GIS, notably the founding of Esri in 1969. The evolution of GIS has been slow and steady, but the foundations and the aspirations and capabilities were there. The advent of modern GIS. After the evolution of GIS followed what could be referred to as its revolution. It was during the 1980s that real development took place, with the software taking advantage of developments in computer hardware. Hardware became more powerful, ran quicker, had greater capacity, and became more reliable and, more importantly, more affordable. Key hardware developments that were most notable were the Unix workstation and the personal computer. The development of computer software kept pace with better operating systems, and importantly, the development of GIS software leapt forward. There was the arrival of a raft of powerful, easy-to-use and affordable GIS software that ran on desktop PCs. Due to the arrival of these desktop GIS products that were easier to use and were affordable, the number of users increased rapidly and they became more capable of using the real power of GIS software. This, in turn, placed more demand on GIS for use in new and varied application areas. Coupled with this was also the age of digital data, where the sources of data for use in GIS became more detailed, accessible and affordable. For example, global positioning systems, GPS, satellite imagery and scanning. Modern GIS developments. More recently, there has been the development of a number of free open-source GIS software run on a range of operating systems. This has been the result of the large extent to which key market sectors such as government departments, transportation and defence use geographic data and this data for analysis. The development and expansion of open-source GIS software has been a distinct move to reduce the cost associated with dependency on commercially available GIS software, the desire to easily extend its capability, and the difficulty of sharing geographic or geospatial data between systems. In 1994, the Open Geospatial Consortium (OGC) was established. Currently, the OGC is an international industry consortium of 426 commercial, governmental, non-profit, university and research organisations worldwide, collaborating in a process to develop publicly available open standards for geospatial data and services to support the continued development of spatial analysis and data sharing. It has been timely, as the Internet was a huge leap forward, and its effect on GIS has been the concept of viewing GIS data over the Internet. Also, the increasing availability of spatial or geospatial data to the public. There has been an explosion of mapping applications on the web, such as Google Maps and Bing Maps. These websites give the public access to huge amounts of geographic data, with these web mapping services beginning to adopt features more common in GIS, such as allowing users to access and annotate maps and share maps with others. If you are keen to learn more about the key historical events in the development and growth of geographic information systems from their conception in the 1960s to the present day, the GIS Timeline project is available and is free to use.